Con questo evento Matrox, per noi Matrox è un partner molto importante. Negli ultimi anni stiamo lavorando con loro negli ultimi 2 anni e mezzo. Abbiamo trovato un partner molto attento al mercato italiano, alle necessità del mercato italiano. E abbiamo trovato un'azienda che è sempre pronta a innovare e lo vedremo anche oggi con delle interfacce particolari in 2110 che sono innovative. Abbiamo con noi oggi Luciano Frigoli, che è rappresentante italiano di Matrox, e Donald Searwright, sorry se the surname, thank you for coming. And lui è sostanzialmente il responsabile europeo della parte broadcast di Matrox. Oggi vedremo, buongiorno, ciao. Oggi vedremo le soluzioni per l'encoding, per la produzione remota. Poi faremo un breve recap di tutti i prodotti riguardanti il 2110, convertitori ST 2110. Poi parleremo di gateway IP to IP e di alcuni nuovi KVM della nuova generazione. E come ultima cosa importante avremo qualche slide sull'origin. Su questo però potremo poi rivederci o riparlarne nel dettaglio perché è una soluzione per la quale ci vuole molto tempo, ci saranno anche molte domande. Lascerei la parola a Luciano per partire, poi a metà faremo una pausa, la durata è circa 2 ore, quindi staremo qua la mattina, abbiamo anche sia un po' di brioche che poi qualcosina da mangiare anche al termine. Grazie mille.
Grazie Mauro e grazie ancora a tutti voi per essere qua presenti all'evento. Come diceva Mauro, l'intento di Matrox, che è un brand presente nel mercato broadcast da tantissimi anni e soprattutto presente in una veste anche diversa. Noi oggi siamo qui a spiegarvi quali sono state le novità durante l'IBC, che sono state parecchie, quello che sta facendo Matrox oggi e poi il mio collega Donald entrerà più in dettaglio in un nuovo prodotto che si chiama Origin e una piccola spiegazione su quello che sono i prodotti OEM e i nostri partner OEM, che sicuramente sono prodotti che voi ben conoscete perché sono vestiti da altri brand. Allora, incominciamo a capire quali sono state le novità dell'IBC che sono estremamente innovative. Innanzitutto, allora, un nuovo prodotto che è stato presentato all'IBC si chiama Avio, è un KVM IP ed è il primo KVM IP NMOS compatibile. Qui troviamo alcune spiegazioni su quelle che sono le applicazioni di Avio 2. E come potete vedere si configura nel network attraverso la rete e qui trovate il transmitter, la server room e i receiver. Lì trovate sul vostro posto alcuni datasheet, se non sono corrispondenti alla slide che state vedendo potete poi raccoglierli qua sul tavolo. I prodotti che stiamo spiegando oggi sono visivamente anche su quel tavolini e li potete appunto poi analizzare dopo e eventualmente quando faremo domande, riceveremo le vostre domande, possiamo parlarvi col prodotto disponibile. Avio 2, qui troviamo alcune caratteristiche, HDMI IP, supporta 3840 x 2160, 60 megabit, 60 Hz, supporta HDR e HLG e la rete network da 1 a 10 gigabit. Queste sono le performance che ha questo prodotto, è in grado di gestire non compresso 4K 30 su 10 gigabit e 4K 60 con un dual gigabit, 10 gigabit. Oppure è in grado di avere una visualizzazione lossless su 1 gigabit e 10 gigabit utilizzando i codec Pro AV e JPEG XS, che è un'opzione una licenza che viene inserita a livello di upgrade. Avio è configurabile, quindi è un singolo prodotto che può essere configurato come trasmitter o receiver, e questo lo può fare il cliente direttamente o si può fare durante il setup iniziale durante l'installazione. È disponibile anche un rack mount può montare due avio su una unità rack. Chiaramente è sia fibra che rame per quanto riguarda il network, SFP, il controllo RJ45 oppure media e control attraverso l'SFP. Full redundancy 2022-7 e la redundancy anche sul power supply utilizzando il Matrox NRG, che è un power supply, una unità rack con ridondato, e lo stesso power supply viene anche utilizzato su altri prodotti simili. Quindi redundancy assicurata. Per quanto riguarda l'audio, l'USB 2 Avio è in grado di gestire l'audio stereo, analogico e digitale attraverso l'HDMI. L'USB è disponibile per eventuali hard drive, joystick o touchscreen. L'USB 2 multimedia device, tra i quali eventuali speaker o soundbars. Sull'immagine vedete esattamente quali sono i tipi di connessione. Per la sicurezza del KVM chiaramente dispone anche di una protezione password su ogni singolo device e anche l'accesso all'user management è protetto dalla stessa password. L'audio ha un encrypted sia per quanto riguarda l'audio, il video e l'USB. Quindi massima sicurezza sull'operatore che riceve il segnale dal KVM. Dispone di il controller attraverso un browser base. Qui vediamo sull'immagine una semplice descrizione di quello che è in grado di configurare, e chiaramente anche di una API oppure attraverso l'NMOS per il routing. Questa è la famiglia dei KVM che dispone oggi Matrox, KVM IP, quindi l'XTO3 che è un prodotto che già esisteva precedentemente all'IBC e i nuovi Avio 2 IP, più il KVM Link che è lo switch per controllare appunto i vari device. Facendo un passo indietro, vi ricordo qual è la famiglia dei prodotti XTO3 che, torniamo indietro di un passo, sono disponibili sia a livello di box, quelli che trovate sul banco, ma c'è anche una versione a scheda da inserire all'interno del PC. XTO3, versione IP, qui trovate una breve, nel diagramma blocchi, l'applicazione su cui viene gestito, è molto simile all'Avio, è limitato chiaramente nella parte network. Tipico workflow dell'applicazione KVM, segnale parte attraverso il trasmitter, qui abbiamo 3 receiver, quindi 3 operatori che potrebbe essere il controllo audio, potrebbe essere il regista, la post-produzione, controllo mixer, e attraverso un singolo device riescono a splittare gli arrivi. Il XTO può lavorare attraverso receiver di segnale network, che può essere una LAN, una WAN o addirittura attraverso internet, quindi nel caso di un OB-WAN può essere collegato attraverso un internet e la produzione ricevere il segnale KVM in remoto. Questo è esattamente quello che stavo spiegando, la situazione di un tipico OB-WAN, dove gli apparati sono sull'OB-WAN, ma gli operatori sono in un'altra locazione, e attraverso gli XTO, i KVM IP o tradizionale o l'XTO3 si inserisce il trasmitter all'interno dell'OB-WAN e il receiver in produzione. Una breve spiegazione su quanto riguarda la configurazione del monitor. i singoli device può splittare su 4 monitor il segnale, può essere lo stesso segnale, la stessa workstation, oppure può suddividere su 4 monitor diversi con lo stesso tastiera e lo stesso operatività le workstation che sta ricevendo, può essere il server, può essere il character generator o altri device collegati al KVM. Quindi, in poche parole, un singolo operatore può controllando semplicemente spostandosi con il mouse tra un monitor e l'altro, oppure ci possono essere 4 operatori diversi, ognuno controlla il proprio device. Adesso passiamo a un'altra novità Matrox che è stata annunciata all'IBC, è un prodotto che si chiama Vion IP Gateway, Video Gateway. Un po' di cronistoria su quello che sono i gateway. Allora, nel baseband, diciamo, si parte sempre dai segnali che può essere HDMI o SDI. Per quanto riguarda il mondo IP, nella conversione si passa da HDMI e SDI in IP e dall'altra parte si riconverte ancora HDMI e SDI. Ma nel mondo IP to IP chiaramente ci sono delle complessità di compatibilità tra i vari segnali che dobbiamo gestire, e qui è dove Vion, che è il prodotto che Mauro ha tra le mani in questo momento, diventa utile e trova il suo scopo di esistere. Per esempio, vediamo la varietà di formati e codec che attualmente sono disponibili, per esempio dall'H264, l'MP4, l'AVC, JPEG, oppure i formati streaming, SRT, MPEG-2, IPMX, e chi più ne ha più ne metta. E per ultimo NDI. Tutto passa attraverso il cloud, però poi bisogna gestirli sia in partenza che in arrivo. E quindi ecco che ancora una volta dobbiamo creare il bridge tra i vari formati e i vari codec. Quindi segnali che riceviamo attraverso la LAN o la WAN o che dobbiamo ricevere, riconvertire e rimandare su internet e sul cloud. Quindi dobbiamo creare l'interoperabilità tra encoder, decoder e transcoder, e noi lo facciamo con un unico prodotto. Encoder to decoder, come dicevo, vuol dire passare da un SDI a HDMI, quindi un segnale digitale, a un H264 attraverso l'SRT, transcode tra un NDI a un H264, tra un H264 e un H265, transmux tra un NDI, un RTX, SRT, transrate tra un formato da 30 a 60 o altri, o H264 o H265. Quindi ecco che entra in funzione il nostro nuovo prodotto che si chiama Vion, come dicevo all'inizio, è appunto un encode, decode, transcode, transmux per live video. È quel piccolo box che avete visto poco fa. Abbiamo 2 versioni, la prima versione è l'NX, N sta per network, quindi è in grado di gestire i segnali IP, e qui lo troviamo nell'immagine. E poi la versione EX, che oltre a gestire i formati IP è in grado di interfacciare anche la parte HDMI e SDI. E troviamo nella slide appunto la differenza tra la versione NX e la versione EX. Qui troviamo il retro del prodotto, come vedete ci sono dei mini BNC dove vengono collegati i segnali SDI oppure l'HDMI, e questo è disponibile attraverso la versione EX, come vedete in questa slide. Quindi oltre il prodotto diventa a questo punto, come dicevamo all'inizio, encode, decode, transcode, transmux for live video. Nella tabella vedete tutti i vari formati che sono gestibili da Vion, quindi nella versione X SDI HDMI e nella versione Nectar oltre trovate anche tutti i formati, diciamo, dei codec di streaming, quindi in grado di convertire in tutte le versioni. Nella demo che è stata fatta all'IBC avevamo 2 unità, una NX e una EX, e con 4 segnali in ingresso abbiamo gestito 11 segnali in uscita. Qui vediamo appunto il Vion EX a cui arrivavano segnali 3G SDI più NDI. Nella versione NX arrivavano streaming ST2110 e SRT e come vedete in uscita abbiamo portato questi segnali in 11 diversi protocolli, in 11 diversi segnali utilizzando due Vion. E qui nello specifico, appunto, passando dal baseband encoding, siamo arrivati a un Premiere on Cloud per il Cloud Contribution, quindi anche qua prendendo i segnali 3G SDI, convertito, abbiamo creato altri 3 segnali in uscita. Baseband encoding, anche qua è un'altra applicazione che possiamo ottenere con Vion. Vedete che appunto il segnale passa dal 3G e viene convertito. Troviamo anche la conversione per esempio dal 3G SDI all'HDMI, quindi un classico encoding, ma allo stesso tempo diventa ingresso-uscita per i formati IP. SRT transcoding, Cloud to on-site prem, nella versione NX. Il prodotto, come dicevo, è stato presentato all'IBC, sono disponibili già da qualche mese i primi sample che i nostri partner possono avere a disposizione e le prime unità stock della versione NX è disponibile da, qui c'è un errore, gennaio 25, non 24, da gennaio da questo mese. Quindi abbiamo mantenuto ciò che abbiamo dichiarato e annunciato all'IBC. Prego Mauro.
Non so se... ok. Scusate, uso il microfono perché siamo in streaming. Volevo solo...
Se tu vuoi aggiungere tanto.
Sì, no, sicuramente è un'interfaccia interessante, anch'io pian piano, ogni volta che la vedo trovo qualcosa di nuovo. JPEG XS sicuramente è interessante, credo, per qualcuno che è qua con noi, perché stiamo lavorando su altre cose, però volevo capire qualcosa di più sul formato IP-MX, credo che si chiami.
Sì.
Perché è un qualcosa che non so se nel nostro mondo non credo che sia frequente. Non so se Donald può dirci qualcosa, o va dopo nei dettagli,
sì,
ok.
Sì.
Era solo perché è un qualcosa che
giusta
è un po'
domanda,
fuori da
anzi.
quello che noi normalmente tocchiamo.
Sì.
Grazie.
Prego, grazie delle domande, anzi se qualcuno ha domande o quesiti da porre o possiamo gestire live oppure a seguito delle presentazioni.
Io ho una domanda sul Vion. Sì, la domanda sul Vion se ha anche possibilità di fare format conversion da IAP, da 50 a 60, questo genere di processing.
Sì.
Ok,
sì.
Grazie.
Prego. Da questa slide, per chi conosce già i prodotti, vi spiego un piccolo product update di quelli che sono i prodotti preesistenti all'IBC, ma faccio anche un refresh di quello che sono i prodotti stessi. Partiamo col Monarch Edge, che è uno dei prodotti che Matrox ha disponibile già da un paio d'anni, ma che è cresciuto moltissimo negli ultimi anni e soprattutto negli ultimi mesi. Era un prodotto nato essenzialmente per la remote production, quindi in grado, ecco, quello è una delle versioni, che abbiamo. E dall'IBC abbiamo semplicemente, con aggiornamenti software, è diventato un prodotto che, oltre che per la remote production, encoding decoding, è anche un prodotto per la contribuzione. Vediamo innanzitutto quante versioni esistono di Monarch Edge. Allora, quello che state vedendo in questo momento fisicamente è la versione S1. Allora, è encoding decoding, quindi è in grado di codificare e decodificare, quindi un canale in, un canale out simultaneamente. E poi abbiamo la versione E4 e la versione D4 che gestiscono 4 canali decoding o 4 canali encoding. Alcune caratteristiche importanti di questi prodotti: l'interlacing, in grado di gestire il 4K senza costi aggiuntivi, ha 2 SFP e, cosa molto importante, è genlockabile, quindi se arrivano segnali, se partenza ci sono dei segnali asincroni, con la parte che riceve i segnali basta aggiungere il gello che si sincronizza con tutta la vostra post-produzione, con tutta la vostra produzione. Ha il tell e il talkback. Domanda?
Una domanda veloce. Gestisce anche HDR e pass-through del Dolby?
Giusta domanda. Allora, il pass-through del Dolby, yes o no? Ci stiamo lavorando. Invece la prima? Anche all'HDR ci stiamo lavorando. Nelle release sono le feature che appunto abbiamo incluso anche sulla base delle richieste dei nostri clienti e soprattutto sulle richieste tecnologiche che avvengono. Allora, per quanto riguarda il Dolby dovrebbe essere nelle prossime release, quindi parliamo nel prossimo trimestre. Sull'HDR non so se sarà incluso nella stessa, ma sicuramente entro l'anno. E quindi, come dicevo, anche qui il 4K è gestibile già da Edge col prodotto standard, non ha extra costi. Qui troviamo un piccolo workflow che include sia l'Edge che i KVM, quindi remote production e remote operation. Quindi utilizzando i nostri due prodotti, Edge per i segnali video e i Extio KVM per la remote contribution, troviamo una tipica applicazione di uno stadio dove ci sono 4 telecamere, i segnali vanno all'interno di Edge, vanno sul cloud e vengono ricevuti, diciamo, dalla produzione. E le stesse cose vengono gestite a livello di remote operation attraverso l'Extio, il KVM di cui parlavo prima. C'è il receiver e ogni operatore ha l'Extio, quindi il KVM, per gestire e pilotare i segnali che arrivano dallo stadio. Come dicevo prima, l'IBC, perché questo è un prodotto che già esiste da un paio d'anni, comunque sono state implementate importanti nuove feature nella release 2.06 e 2.08 e che lo rende un prodotto anche per la contribution. Quindi è stato aggiunto il multiplexing, MPEG-2, SRT, SRT, MPEG-2 TS, anche questo grazie ai feedback della CVE, e il PCM audio e il Dolby Pass-Through che dicevamo prima, che è Donald ci ha confermato dalla fine di febbraio. Stream ID riprogrammabile I/O, anche questo è una delle feature importanti che riguardano soprattutto l'encoding a 4 canali, mentre prima era encoding 4 canali, oggi può essere configurato, può essere 2-2, quindi 2 in, 2 out, oppure 3-1, 1-3, indipendentemente dalla configurazione, quindi diventa un prodotto più interessante per le richieste. Non c'è bisogno, per chi deve gestire per esempio 2 canali, non c'è bisogno di acquistare 2 encoding da 4, ma con lo stesso encoding fa encoding e decoding. E HLG e PRQ, anche questo nelle nuove release. Cosa importante, le release sono free of charge, quindi chi ha acquistato, chi acquista i nuovi prodotti riceve queste nuove feature.
I/O, nel
Sì.
senso, mi sembrava che ci fossero 2 hardware distinti, uno che fa encoding e l'altro che fa decoding.
Ecco, esatto, quello che fa encoding è riconfigurabile, può fare anche adesso, con questa nuova release può fare encoding e decoding.
Ah, quindi le 4 non sono necessariamente 4 encoder, ma può
Esatto.
funzionare anche
Da
come...
oggi sì. Da oggi sì.
Il D4 invece è solo
No, quello
decoder.
rimane decoding.
Ah, ok.
Quello è un hardware specifico,
Ok.
mentre l'encoding è in grado di fare anche decoding e quindi con l'aggiornamento software abbiamo dato la possibilità di programmarlo, che di fatto è un po' quello che deriva dalla versione S1, che è già encoding e decoding, mentre abbiamo applicato le stesse feature, la programmabilità sull'apparato che ha già 4 input, semplicemente riprogrammandolo.
Perfetto,
La
grazie.
parte più complessa è l'encoding, quindi diventa abbastanza semplice riconfigurarlo. Quindi, come dicevo, qui cosa importante, sono feature che sono state implementate nel software e chi l'ha acquistato precedentemente deve semplicemente aggiornarlo, chi l'acquista oggi o con l'arrivo della versione 2.08 che, come diceva il collega Donald, sarà a fine di febbraio, li avrà inclusi free of charge. Quindi il prodotto, che comunque ha 2 anni di età, è oggi più maturo e soprattutto trova altre applicazioni. Altro prodotto interessante che è stato annunciato all'ANIB dell'anno scorso è il Convert IP. Convert IP è un altro box che, appunto, lo dice la parola, è in grado di convertire segnali in IP 2110 e IPMX. Qui esistono diverse versioni del prodotto, ci sono attualmente 7 diversi modelli in grado di gestire l'SDI o l'HDMI nei vari formati. Qui nella tabella vedete la differenza tra un modello e l'altro. I modelli si differenziano da DSS, DSH, DRS, DRH, eccetera, eccetera. E sulla tabella vedete le differenze tra uno e l'altro. Quindi il prodotto è ideale per il 2110 monitoring, attraverso da ST2110 a 3G o 12 GB SDI o viceversa. Il prodotto è configurabile, quindi può essere convertire in un senso o nell'altro, oppure da 2110 a HDMI. Ok, come dicevo prima, i device sono gli stessi e sono configurabili, quindi per una direzione o per un'altra, per un encoding o decoding. Qui sulla destra trovate la differenza tra i vari modelli. Come dicevo prima, esiste la versione SDI, quindi dispone dei BNC più gli SFP. La versione HDMI dispone appunto delle uscite HDMI in e out e chiaramente gli SFP. Quindi qui troviamo le caratteristiche di base sul prodotto, standard 2110, NMOS enable, quindi può essere controllato NMOS, può funzionare in modalità lossless, e 0 latency, che è la cosa molto importante. La flessibilità di lavorare anche in non compresso oppure JPEG XS con lo stesso prodotto, basta aggiungere la licenza JPEG XS. HDMI o SDI in grado di convertire l'interoperatività tra i vari segnali, il workflow complesso da sui 10 o 25 gigabit con Ultra HD sulla fibra, o JPEG XS workflow HD o HDMI da 1 giga a 2.5 su rame o su una network in fibra. Supporta il 2022-7. Questi sono degli unique selling point di questo prodotto. In particolare ha una porta indipendente per il controllo, fanless design, quindi anche questo posto nella vostra production room, comunque non si sente perché è estremamente silenzioso, controllabile attraverso una web page e NMOS enable oppure l'API. Configurazione molto semplice e facile anche da sviluppare. All'IBC di quest'anno è stato introdotto una nuova versione, aggiunto una nuova versione che però è, diciamo, dedicato ai videoproiettori, quindi è basato sull'Intel Smart Display Module. Quindi eccolo qua, praticamente è lo stesso prodotto basato sulla scheda Smart Display Module, che è uno standard disponibile su molti videoproiettori, quindi voi arrivate col vostro segnale IP direttamente al videoproiettore e viene convertito direttamente dalla scheda all'interno del videoproiettore. C'è uno slot dedicato e ideale appunto per chi fa rental o staging market. Le caratteristiche sono molto simili alle versioni appliance, quindi qui trovate le caratteristiche. La disponibilità è da dicembre dello scorso anno, quindi è da un mese che lo stiamo consegnando. Qui vedete la scheda come è formata. E questi sono attualmente i display, proiettori, i brand che supportano questo tipo di scheda. Quindi anche questo è un nuovo, magari più nel settore AV che non nel settore broadcast, però è giusto per farvi capire che utilizzando la stessa tecnologia abbiamo creato questo nuovo prodotto che è molto interessante per questo tipo di applicazioni. Tra le nuove feature che riguardano tutti i converter IP, quindi le 7 versioni più quest'ultima, abbiamo aggiunto nel receive mode il quad split, il che fa pensare che potrebbe anche essere utilizzato come piccolo multiview IP. Anche qua abbiamo semplicemente, aggiornando il software, chi ha già acquistato il prodotto lo può aggiornare e questa feature viene attivata nei nuovi device. Quindi chi l'ha acquistato basta che aggiunga il firmware, chi lo acquista ora ha già questa feature inclusa. Quindi oltre alle applicazioni e alle feature che descritte prima, quindi come convertitore tra l'SDI e l'IP, i formati IP, ha anche un quad split che alcuni trovano applicazione utilizzandolo come piccolo multiview. Ogni modulo fa 4 quad split, quindi avendo 2 moduli si hanno 8 e così via e so on. Queste sono le caratteristiche di monitoring che ha questo quad split, quindi YOV, RGB o mix, ogni quadrante può essere configurato in un modo o nell'altro e appunto è disponibile per queste versioni. E supporta tutti i codec JPEG XS o Pro AV codec. End of the year si intende precedente, dicembre, non quest'anno. Qui troviamo l'applicazione, anche questa è un'applicazione che è stata sviluppata in quest'ultima release, quindi può essere anche un IP gateway per convertire JPEG XS ad uncompresso oppure ProEV ad uncompresso o viceversa. Quindi anche qua chi ha già acquistato il prodotto può semplicemente aggiornarlo, chi lo acquista oggi ha questa nuova feature inclusa. Altre conversioni possibili con il Convert IP, quindi da SMPTE 2110 a IPMX o viceversa, da 20.22.7 da non 20.22.7 a 22.22.7 o viceversa, da HD a 4K o viceversa, da YUV a RGB, PTP Locked Workflow o Unlocked Flow.
Ci sarà anche qui l'HDR, possibilità di aggiungere LUT per fare SDR to HDR?
Oh, good question. Do you know if it's possible to convert the HDR?
In SDR to HDR with LUT? Maybe?
I do not, but send us that question and we'll find out.
Okay,
Welcome.
thank you.
Quindi tra formati di produzione e formati di distribuzione, anche qui trova applicazione il Convert IP. Qua sicuramente siete più informati di me su quelli che sono i vari formati e appunto con il Convert IP è in grado di rendere compatibile o convertire i formati tra uno standard e l'altro. Anche questo disponibile con la nuova release. NMOS come routing solution, Convert IP è appunto supporta il NMOS, quindi c'è poi una improvement per quanto riguarda il controllo web, nuova productivity feature e soprattutto diciamo con l'NMOS siamo in grado di gestire sia il Vion che l'Avio 2 e tutti i device NMOS compatibili e IPMX. Fatemi tornare indietro. Qui passo la parola a Donald. Donald. Yeah. If you don't mind, I'll let you go through the IPMX slides. Yeah. Just the last few slides.
To answer your question regarding conversion between HDR and SDR, the problem is what kind of conversion do you want? Because converting is very dependent on the actual material you're wanting to convert. You know, so I don't know if we're going to do that in the box, but the lookup tables you want to use for any particular content can change, as I'm sure you encounter in your productions.
Basically, my question is for soccer production.
Yes.
So it means that HDR is HLG. So
Yes.
basically, if I have HLG production, what I would like to have is from HLG to SDR,
Yeah.
basically, or vice versa.
Yeah, I mean, I still have to check whether the converter mode for the Convert IP will do SDR to HDR. If it does, it will certainly do HLG. That's not a problem. We already have that technology in-house, so that would be fine. The problem we have is the lookup tables you use within HLG change depending on the content to get the optimal output. So, because we've done a huge amount of work on conversions between SDR and HDR, and it's very difficult to get one lookup table that works for all content. And I suspect that might be the problem, but I'll find out.
Thank you.
Yeah. IPMX. Does anyone know anything about IPMX here? Okay, as a very, very general idea, it's like ST2110. It's very similar. It's based on the same series of standards that give you ST2110. Matrox has two divisions. We have a broadcast division and we have an audio-visual division. And I'm from the broadcast division. The AV division wanted to take a lot of the technology that we've developed for the broadcast world for ST2110 and move that into the AV world. Now, ST2110 is okay as a format to use in very high-end productions in the AV market. So, for instance, very large installs where we have to spend a lot of money and where they're fixed installs. But there's a whole range of installs in the AV market which don't require a lot of the features that ST2110 indeed require. And indeed, there's a few features that ST2110 doesn't have that are needed in the AV world. So things like in the AV world, it doesn't necessarily need a -7 signal, which is mandatory in ST2110. It doesn't necessarily need a PTP clock either, because in the AV world, everything doesn't necessarily need to be clocked. However, in the AV world, they want to have things like EDID control or EDID support, so they can automatically send things out to a display, because their output is very often a display rather than a hard specified broadcast resolution. So in a nutshell, IPMX is a standard, an emerging standard. It's going through SMPTE, and there will be an IPMX standard. Another thing about IPMX is NMOS, as you may or may not know, is not mandatory in ST2110, although almost everyone has it. In IPMX, it is mandatory. So your ability to recognize what is available and understand what it does is mandatory in IPMX, whereas you can have different forms of control in ST2110. So I'm trying to contrast IPMX with something you are probably familiar with already. And these are the sort of markets it's aimed at, things that are outside of broadcast, so things like esports and digital signage and things like that. Digital signage doesn't need a -7 backup. It just doesn't. If a screen goes down, it's not mission critical, it just has to be fixed. Military and defence. Military and defence is very important, and there is one vulnerability of ST2110 that I suspect all broadcasters have begun to recognise. Broadcast systems have always been considered separate islands. And in an SDI world, it didn't matter because there's no way to get malicious things into a system and out of a system. They were isolated from the outside world. However, in an ST2110 system, you begin to have to consider network security as a global issue. Inside an environment today, broadcasters generally don't do it. They treat their broadcast systems in the same way they treat an SDI system if it's ST2110. That's not a great place to be, given it's all IP. There are vulnerabilities there that are not there in SDI. So IPMX are working on security extensions for IPMX, so they're more secure for the likes of the military market. And I suspect those same security mandates will come back into ST2110 in due course, because it is a vulnerability. Although the way that the broadcast industry has traditionally worked is you create a firewall around your broadcast system. That's no longer going to be enough, I suspect. And your IT people are probably becoming a little bit nervous about that if you're using ST2110. So that, in a nutshell, is why we did it. It's to broaden the options for deploying digital video over IP applications. That's what we want to do there. And we want to be able to repurpose whatever systems are already there. Expand the technology stack. It supports more codecs than are supported in an ST2110 environment. Because it's not necessarily clocked to a PTP clock, you can actually offer subframe glass-to-glass transports. We'll come on to that actually in the next presentation on Origin as well, but it allows you to transport as fast as possible, not having to wait for the tick of the next clock to pass the video on to the next step. And you don't need synchronous signals. Everything in an ST2110 environment is synchronous. You don't need to do that in an IPMX world. And as I said, it provides EDID and HDCP support. And it's aimed at software-only workflows. Today, you're all using some form of... Who here is using ST2110 today? Yeah. So all your ST2110 systems are built on Mellanox or Matrox hardware. Everything in there that's got some going on. There might be a few bits and pieces that are different, but really that's your two choices. In IPMX, we'd love it to be Matrox, the only choice that was there, but the market is too broad and it goes far too low to expect it will work always in a piece of hardware from either Mellanox or Matrox. So in IPMX, they will support generic NICs as well for different transport. They'll have their own limitations, but the limitations will be what you have to accept for the lower cost for those sort of markets and the greater flexibility you'll get. Transport based in ST2110, and as I say, NMOS is mandatory in IPMX. And the control is based on NMOS. These are both mandatory features. As he did, and content is protected. You in the broadcast world that don't actually, content protection would be a pain for you. Whereas in the AV world, it's actually very important because the AV world is outside, the next step down where you want to protect your content. And so HDCP is important. And there are various options for codecs that can take you down to much lower bit rates than you would ever consider in ST2110. Because the end destination is not the same place as you as broadcasters would expect it to go. This is just reviewing what I said. Sorry, I didn't go through this. I've told you a lot of this stuff anyway. 2110 requires a PTP. It's not required in IPMX. It assumes everything is gen-locked using the PTP clock, and the resolutions are fixed by broadcast expectations, and the aspect ratios are set by that. The AV world doesn't need that. In fact, a lot of AV work doesn't require any of that. They're very odd resolutions sometimes. And there are RGB support is supported in 2110, but it's not really used by anyone. It's very important in the AV world. So the modifications that are made was tweaks to PTP. PTP profile is easy to deploy in software, so you don't need any bespoke hardware. Asynchronous support and more focus on RGB and desktop color spaces. And this gives you an idea of how the standards have been worked on. Matrox are very close to the development of IPMX. We're driving it substantially in-house. If you have any questions, don't hesitate to come and ask us because we've got a lot of in-house expertise. And we actually have a couple of employees who second to AMWA to manage their business as opposed to Matrox business. again, discovery. You know how this works. You use NMOS today, so I'm not going to go through this in any great detail. It's roughly the same. Control of API, used for routing. You know all about this stuff. And EDID management is for non-broadcast type output devices. And content protection. I presume you're all familiar with this stuff, so I won't go through it again since I've already discussed it with you. Yeah, the codec support inside of IPMX is wider, and there's a lot of discussion going on about what are the optimal codecs to be used. Certainly JPEG XS will be supported, but they want other much lower bitrate codecs so that they can use gigabit and 2.5 gigabit networks rather than 10 and 25 gigabit networks. Okay. Okay. These are a few customer success stories we've had. This is Convert IP. It was used by Lux Machina, who do a lot of esports stuff and broadcast stuff, and used virtual production and for live events using Convert IP. The reason they chose it was they wanted the highest quality, and they wanted a zero latency or very lowest latency opportunity or function, and that's what Convert IP offered. And one project, $40,000 of business, more interesting than you for these guys. But you know, the thing about things like Convert IP, you guys who are using ST2110 have a whole bunch of converters around there. You have some large converters, gateways that will do multiple signals in and out, and you have a whole bunch of small converters out there that sit behind monitors and sit in various other places. So the advantage we offer is one series of products that can address all your needs, SDI, HDMI, and a whole bunch of other things. XTO3. PRG are an events company, and they do large events with media servers sitting behind screens. Media servers at concerts and things like that always sit behind the big screens that they're driving, and they sit there because their output is typically HDMI, and you can't drive HDMI very far. So actually, up until now, what happened was the operators sat behind the screen so they couldn't see what was going on. Using XTO3, PRG extended what was going on in the media servers to in front of the screens. That meant the people who were driving the video could also sit next to the people who were managing the audio, so they could involve the whole team in doing the same thing and make a better output for our clients. And substantial amount of money for each project. And the NHL. NHL produce their own content. They moved to 3 big facilities in North America. They don't use third-party broadcasters to produce their content anymore, and they needed to do remote production and their alternative feeds. So the non-main feeds from their games. And the evaluation was they wanted 422 10-bit, which we have in Monarch Edge. They wanted low latency, and they wanted reliable technology, all of which Monarch Edge addresses. And the extra features that we have, the LCD screen in front of the boxes allows you to see configuration data. So if you take a Monarch Edge out the box and plug it in, you can see the IP address of that box directly on the screen in front. It'll give you other diagnostic information. And the BNCs light up when they're connected. It's a usable thing. People like to see that they've actually got a connection. And that was a chunk of business for us. So, thank you very much for your attention. Do you have any questions? And by the way, if I say something too quickly, or if I say something you don't understand, ask me. I'll rephrase or I'll say it slower. I apparently have an accent as well.
Yeah, well, it's not finished, non abbiamo finito ovviamente, c'è una piccola pausa.
Sì, ci fermiamo un secondo e poi abbiamo ancora una mezz'oretta per vedere le altre cose. Va bene? Ok, grazie. Ripartiamo, abbiamo una mezz'oretta, 40 minuti, dove vedremo insomma un po' di cose nuove da parte di Donald e dopo ci salutiamo, abbiamo qualcosina, vi dico già, abbiamo qualcosa da mangiare qua in fondo, la stiamo aprendo adesso, quindi se volete potete fermarmi un attimino anche dopo. Grazie mille.
Okay, so I'm going to speak in English. If you don't understand anything, please interrupt me and ask me to repeat. I'm quite happy to do so. And what I'm going to do, and if you get any questions, just ask me. You know, I'm quite happy to fill in between the presentation. I'm going to talk to you about a product called MATROX Origin. MATROX Origin is a new venture for MATROX. MATROX makes hardware. Everywhere it goes, it makes hardware. We've always had a part of our business which made hardware with associated SDKs, and that's what you'd find in many of the systems you have in your broadcast environments. You have video servers, you have CG systems, you have lots of specialist systems around your broadcast environments, which, whether you know it or not, are based on MATROX hardware, because third parties, CG companies, video server companies, archiving companies will take our hardware, they will integrate it using our SDKs, and they will sell it as their product without knowing anything about MATROX being in there. One of the main advantages we have always offered is we have one common SDK, and that one common SDK allows our customers to go between boards. So if they're using our SDI board and they needed an SD2110 solution, they could use the same SDK, the same code base, they could just use an SD2110 board, plug it into their existing system, and it would typically take them from a few days to a few weeks to make that transition. So what we did and what we do is we abstract the communication and the specification-driven part of the signal from the OEM developers. We manage that. So we manage the SDI signal, and what a developer sees is a buffer. That would be a video buffer, an audio buffer, or an ancillary data buffer. And then they can process it using whatever specialism they have. And if they want to output it, they can do the same, give us a buffer and we'll output it, or they can archive it or whatever they want to do in that regard. That's in the world as it stands today, where there are some kind of physical signal flowing around an environment, be that an SDI environment or an SD2110 environment. We regard what we do today as plumbing. So we manage getting things around your facility, be that SD2110 or SDI. We see an opportunity through various types of serendipity to take that plumbing and move it to an environment where plumbing isn't quite the same concept, but there's still the same requirements from the broadcasters as to how their signals flow through their broadcast environments, their production systems. So, what typically happens today with breast-of-breed software systems? You know, I would guess that few of you have a broadcast system, a complete production workflow from one vendor. You want to be able to choose the right video servers, you want to choose the right CG, the right audio normalizers, etc., etc. The ones that best suit your need. And you'll have your favorites, etc. All of those are connected by standards, as we described. So typically what would happen is we would be approached by those best of breed suppliers, and they would take some of our OEM boards. Now, we produce a whole range of SDI boards, varying densities, and obviously prices, and performance. So some of them have onboard processing, some of them do not. All of those are linked by a common SDK, so moving between boards is very easy. This is what we consider plumbing today. Top of that plumbing, applications run, which is your CG, replay, production servers, etc., etc. And that is what developers provide. So if, that's how we fit into the world of broadcast today. The applications that are typically running today on all of your broadcast equipment are monolithic applications. They're one big application which runs on that box and does something for you. Takes in a baseband signal, compresses it, writes it to disk, things like that. I'm not going to spend too much time talking about this. It becomes very relevant if we deep dive into the Origin product as to why this is important. There are some external features, factors that are pressing on everyone in the broadcast market. The market's fragmenting. Where you're delivering your content is changing. You're not just giving it to a transmission tower and sending it out. There's a whole bunch of other things. It started when people started sending signals via satellite, in fact, where it was no longer regional, it became world broadcasting. Now, now a substantial amount of your broadcasting is actually going online, so people pick up using your applications or via a general platform or something like that. And that's fragmenting what you're delivering. And there are new competitors coming into your market. I'm sure your CFOs are telling you all about that on a regular basis. And those guys are taking your revenue away one way or another. There's different pressures that are happening today. And your advertising revenue, I don't know if any of you individually see this, but if you look at the market as a whole, the advertising revenue for the broadcast market is struggling a little bit from what it's been in the last 20, 30 years. So it's not a great environment. So what you need to do, and what I expect you're being asked to do, is to do more with less. Excuse me. So there's a few ways you can go about that, but there's some obvious steps you can take to address that. Now, we have an objective to be able to do what we do today for you in the sort of environments we think that will give you better price performance for your production systems. Our opinion is the way that you should be considering doing your production is moving away from bespoke systems that sit in a large machine room that's air conditioned and you have individual boxes to do everything, and consider moving it to more of a cloud-based environment. Now, the cloud-based environment doesn't matter whether it's a private cloud, your own data center, or a public cloud, or even a mix of both the two of them. It does not matter, or even a mix of existing production systems and cloud-based environments. However, in order to move to those cloud-based environments, it's a software transformation, because you have to take systems, discrete systems that are sitting in a machine room, and make them do the same thing, ideally make them do a bit better, in a cloud software-based environment. And we have there are some requirements that we've imposed on ourselves in order to make sure that is possible for broadcasters to do without making compromises. So once again, this is the best of breed software environment today. You have software developed by individual applications running on the hardware. The hardware today can be transformed from bespoke boxes that you buy from whichever vendor has them to generic platforms. You know, it can be supplied by AWS or Oracle Cloud or whoever you want to choose. or you can build your own data center. So you no longer need bespoke hardware. That takes one specific cost out of your environment, because today, if you buy a CG system, it's a CG system. You can't really use it as something else when it's not being used as a CG system. The advantage of going to the cloud is you can use that same hardware, going to a cloud, you can use that same hardware for another purpose. So you're actually utilizing your resource much more efficiently, because it's not just one thing. What is the next gen plumbing? How do you plumb it? Because today you have an SDI or SD2110 environment, and you have signals flowing across networks or across coax cable from each individual environment. And you have deterministic performance from that. You know how long it will take from a signal going in to a signal coming out. And that's required for the way you do your business, how you do your productions. You have to know that. So next-gen plumbing has to give you the same sort of capability of predictability and absolute predictability. And do you really want monolithic applications? That's another question. The reason you don't necessarily want monolithic applications is because when something goes wrong, you have to take the whole thing apart. You have to go in and find what's wrong. You have to put it back together and see if you've not broken anything else. It makes maintenance cycles much longer. It makes bug solutions much slower. So actually, if you can break your application into little chunks, and those little chunks can be assembled in the right way to do what the monolithic application did, that's an optimal way for you to get service. There are a lot of other advantages, by the way, which I won't go into today. For those people who are interested in this, we will go into them in a deep dive about the technology. The holistic view of what would be ideal for broadcast or system integrators or whatever is to build a tier 1 capable software-defined media infrastructure. A tier 1 means no compromises over what you're doing today, none at all. And to offer the best of breed solutions, so you don't have to use a solution from one company. There are a lot of cloud-based solutions out there. Most of them ask you to use all or a large number of services they provide themselves, be it servers, CGs, etc. In the ideal environment you could have, you would not need to do that. You could choose the best ones you want to, the one that suits your brand, most importantly. So that's one of our targets. And the other target is we want to do that while operating in an IT infrastructure, just like everyone else on the planet is doing, banks, online retailers, anyone who's doing something in the cloud. The nice thing about aiming to do it in those sort of environments, be them in a private data center or in a cloud-based environment, is that technology will increase in performance much faster than broadcast systems will, simply for scale and drive from the size of the market. If you can do it in there, you're pretty much guaranteed to have better performance year on year without touching anything else. And there's also a lot of other advantages there. Cost per compute node, etc., is generally much lower, etc., than it is in broadcast environments. This is the challenge of how you achieve it. Now, I won't spend too much time on this because you know what this looks like. This is a typical broadcast workflow. You have an input, and you have an output, and you have a whole series of processing blocks between the input and output. This is a gross simplification because, of course, you've got many branches going off that, but it's roughly what you do today. And each one of these blocks is timed to a clock tick. Every time the clock ticks, the data can go on to the next thing. Now, some of the processing steps take more than one clock tick, so there's delays in there. But that's roughly how you do it. You do it with either a Genlock or a PTP clock to go through the system. And that determines how long, the minimum amount of time it will take to go through your system. Even if you can do the individual processing faster than one clock tick, it's still going to take a clock tick for that step. It's clock driven, it's synchronous, and it's physical. You get physical kit that you can go and touch and feel and move about, etc. The challenge is much more like this. You have a whole bunch of processing resources that sit in a network. These are all high performance networks, they're very high transport levels. You have a whole bunch of processing nodes, and the data can go from any processing node to any other processing node, any way you really want it to. So your linear processing is no longer necessary inside of a cloud-based environment. Now, the linear processing is still required because you still need to do things in the sequence. So you need to have some control to make sure that happens. But you don't necessarily have to do anything on the clock tick anymore because it doesn't care. In the IT world is not synchronous. If you send a task to your computer, you do a calculation in Excel, it doesn't wait for a clock tick to give it back to you. It just gives it back to you as soon as you have it. So a generalized IT environment gives you an advantage. You can do processing faster where it is possible. You don't need to wait for the next clock tick to send the output to the next step. So, still, the challenge is how do you do this? And again, I mentioned it earlier, you have to do it with any compromise. We would not be doing what we're doing here if we felt we had to give you a compromise. We're not saying, but you have to do it this way or you have to expect this. So, the kind of things we mean by no compromises, we don't expect to limit the number of inputs you can use. We don't expect to limit the number of outputs you can use. We don't expect to limit the type of processing you can do. We don't expect you to have to wait for longer for your production, your data that's coming in to come out the other end of your production. We expect you to have at least the same performance you have today in every single area. That's our brief. And what do you need to have in order to make television as you do today? Ideally better, but as you do today. It must be frame accurate. The audio and the video and the metadata need to be aligned on the output. And they need to be aligned in the input, because if you don't align them in the input, you don't know how to align them in the output. So you need frame accuracy. You need low latency. The lower latency you can get, the more you can do in a particular workflow, and the better performance you can give to your customers on real-time live production, etc. It has to be responsive. When you're using a mixing desk or a switching desk, when you press that button, you expect what you see on the screen to change. You expect your actions to happen as you expect them to happen on the frame that you require. You need redundancy. So you need some way to make sure that if one particular workflow goes wrong or one particular process goes wrong, that you can have another process that will take over from it seamlessly, so the client does not see any difference, doesn't see any glitches, doesn't see any change. You need clean switching, of course. That's a given. Can't possibly not give you clean switching. And the environment needs to be observable, because today you can see, you know how long it takes to go through any particular device in your workflow. You need to be able to see in an IT environment how long it's taking for each process and how the process is going on. You also need to be able to observe where something in the process is not behaving as expected for whatever reason, a potential of warnings or go to other workflows, etc. So these are all things that you need to have in order to consider going to the cloud, in our opinion. Build a tier 1 software-defined media infrastructure with best of breed. So select whoever you want for live while operating IT infrastructure like everyone else on the planet with no compromises. The product we've designed for that is Matrox Origin. I'm particularly keen on Matrox Origin because I saw it, the very first demonstration that to anyone outside of the guy that came up with the idea was to me. So I feel quite a personal attachment to it. And we started this about 5 years ago, the development was started. We launched it at NAB 2 years ago, started to discuss with people, and it moves on. So, this is a schematic of how a broadcast workflow works from a very high level. You have inputs here, can be 1 or 100 cameras. You have an output over there, which is what your client sees, and you have various control inputs. You've got lots of control inputs in reality, saying do this, do that, and someone makes a decision to do this, etc. So those are roughly your 3 input requirements. And you have a large processing capability in the moment. And this is general to what you do today as well. This cloud area in the center could be your machine room today, or your OB van, or whatever it may be. In order to move this to a cloud-based environment and take advantage of asynchronous processing, you need to have some requirements. Now, the technology stack that we have on Origin looks like this. It will run in public cloud or on-prem systems. So you build your own private cloud, you can use that, or you can use public cloud, or you can use a mixture of both, which is quite good for overflow requirements. You know, you have your standard system on-prem to do day-to-day productions, and then when the Olympics or the World Cup comes out, you can just rent additional capacity somewhere else. It means you don't have to over commit to equipment that you require today. Helps with your cash flow. You can also utilize the same technology you have today in your video servers, etc., as edge devices, because it's not going to be all IP workflows that you have today. You're still going to have SDI cameras out there. You're still going to have microphones coming in. You're still going to have other metadata coming in that's not coming in as the signal you'd expect. So we still have these edge devices here, and these are our edge devices here that are, again, our OEM boards. I'll tell you a little bit more about them in time. On top of that, we have a media-aware framework. The media-aware framework is the secret sauce we have here. It's essentially a large database that understands all of the video, all of the data that's associated with your material, and that is, it understands the video, it understands the audio, and it understands the metadata. It keeps them separate and allows you to manipulate them. Top of that, and at that level, this has to allow scalability. Has to allow you to increase the scale of your production as you require it. We can scale production on the fly. You don't need to stop production. You can do more, scale up and down dynamically using this environment. It offers timing. We'll tell you about how the timing works in a second. We've actually been doing this sort of timing for about 20 years, but just on their boards, we've scaled up to a complete IT infrastructure. This manages the flow of the data through your production system, and it also provides a resilience. So ways to back up workflows, etc., and make sure if one workflow fails, that another workflow is available. And we call this the Asynchronous Media Framework. The product was originally called AMF, Asynchronous Media Framework. On top of that, there are media services. The media services are the products you used to do today, the replay servers, the archive servers, the CG, etc., etc. This is where you have, this is the things you really interact with today, and they sit on top of the media-aware framework. And they're all timed. That's why we've got a graphic there. These have to be timed. The processing and the sequencing of it has to be timed and aligned. And all that processing is done via C++ API. That's what's done today on the discrete boxes you use, and that's what will be in the same environment. So people, third-party software developers, I don't know, Imagine or something like that, could take what they're running on their box today and they can port it directly without touching it into something like this. We call that lift and shift. It's a suboptimal way to take advantage of the framework, but it's absolutely possible to do it. And it has limitations, but it has the advantage of not requiring a lot of engineering effort. So you can do that while you're working on your optimized version. On top of that, there has to be a controlling application. You've all got automation and control systems today sitting on top of your machine room, controlling what's going through there and setting them up as required. So those need to be available as well. And that controlling application, those controlling applications, and that could be from wherever you want, whether it's Morpheus from Grass Valley or from AN other control application. You have a control environment, and that talks to the media services in the same way it does today, using a REST interface, an HTTPS REST signal. And on top of that, you have an orchestration and monitoring. You have to know that everything's running okay. You have to make sure that you have the right resources available for what you're going to do next, etc. So this is the technology stack that we've developed for Origin to allow people to create a complete broadcast workflow. This actually won't look very different from the technology stack you have today, except the media services are actually discrete boxes as opposed to software running on a general PC platform. Now, we provide the asynchronous video framework. We supply the C++ API interface. We supply the web API for communicating with those services. And we also supply the metrics to monitor what's going on in the environment, the monitoring on the media-aware framework. And that's where automation and measure, etc. will happen. So, system architecture, I'm not going to take much time over this slide. Controlling application sits on the top. It speaks via REST API to an AMF server. Now, the AMF server can run across availability zones, and we can mirror the AMF server to other availability zones as well. So, depending on how worried you are about failures, there could be a system failure where a complete data center went down. It does happen now and again. So you probably do not want to run all your production in one data center. So you can run the same production in 2 data centers. You can actually run individual applications on different data centers if you want to do it inside an availability zone. You may also wish to run a backup service of your outputs, of your production, in a completely different, in another availability zone. You might want to do, I don't know, Italy, or you might want to do, LA or something like that, whatever, and to make sure there's nothing regional that interferes with your production. You can do all of that using the AMF server. It controls the individual processing capabilities, a host where all the processing will be done, and then there's real-time input and output. The host will do whatever it needs to do, and the difference between the input and output is the glass-to-glass time. Now, I won't get into this next bit. We can talk about that should you have an ongoing interest in this. And the important thing is all these hosts connect to the same content transport fabric. That means that if a host goes down for any reason, another host can be running at the same time doing exactly the same thing to the same buffers. So if one host goes down, the second host just fills in where the other host went down. In the content transfer fabric, we have a function. Basically, all processes are take one buffer, process it, output that buffer. That's the output of your device. We have a polling system whereby multiple processes can be doing the same process at the same time. The first process to output a result outputs that result. So, and it signals to all the other processes, stop now. The output is done. That is redundancy. Now, the advantage of that is those other processes could be running in just another host, another availability zone, or another data center, or another availability zone. And it would just fill in the same thing. So that's very localized redundancy for each individual process. It also means that if there's a particular function that's not behaving as expected or is upgraded, you can swap them out real time without interrupting your workflow. You don't have to switch anything. It also means if you have processing going on, your television's output overnight is not typically very high production demand, because not that many people are using it. It's not that sexy what's going out at night. Through the day, when there's a football match on or something like that, your requirements for processing go up substantially. You can actually scale and add processing dynamically without taking anything off there. You can just add additional processing nodes, and as the processing requirement goes up, you just add them into your workflow. Actually, let me see. Let me go back just a second, because there's one bit I realised I didn't tell you, and maybe I deleted the wrong slide. I did. I'm very sorry. I forgot to tell you something. At this point, how do we do all the synchronization and control? When anything comes into the system or goes out the system, there's a timing. There's a timestamp when everything goes in and out. Now that timestamp is the same for everything that comes in at the same time. Audio, video, metadata, any control signals going at the same time. So that's how you do real-time frame accurate switching. You know that frame you're seeing in the display is the one you want to switch on. You press the button. That button relates to what you're seeing there, because we can tell because of the timestamps. Now this timestamping means that when you take all that data and you send it through any synchronous process, the timestamping stays with the data. That's what the asynchronous media framework does. It maintains that timestamp. So you can do the processing in any order you want and at any speed. Audio processing typically is much quicker than video processing, so audio is probably going to come out a bit earlier out your workflow. But you just buffer that at the end and wait till the appropriate frames for video come out, and then they're ready to go back out to glass. So you no longer have to worry internally about how processing is done, as long as it is done in the time you need it. You align it on the output. You don't care about whether they're done synchronously internally, because they no longer need to be, as long as you can align them in the output. Now, we know this works because our OEM boards do this already today. So there's really no problem in doing that. So let me go forward a little bit. And these are, now, in order to achieve a workflow, you need components to sit on this, this media framework. Now, these are the components that we have today that we can announce. These components, the ones here, are all ones that we create. So we'll give you input and out devices, SDI, SD2110, NDI, SRT, blah, 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 and a whole bunch of other services that you have there. You'll be using our file readers and writers as well as part of some of the systems you have. They've been used for the last 30 years in that regard. So these are all things, services you can get from us. These are not services that need to be unique to us. If you want someone else's services, you're perfectly welcome to implement them inside of Origin. We would like you to use their services. We think they're very good. If you don't want to use them for any reason, you can implement any other server you want, any other service you want. These companies, third-party companies, have already implemented various services, their larger services into to Origin. There's a whole bunch of other people working on them just now, and some people that are just waiting for the right broadcaster to say you need to do this, and they'll come and they'll do the implementation. As I say, there's two different ways they can implement it. It's quite simple to do at a high level. The lower level stuff is they're only going to do once they've got business on that. And we deploy it. We deploy the environment you're going to use using Terraform. So it's quite easy to deploy the hosts and the processes running on those hosts. These are the guys who are already on board, so we've got frame rate conversion, and we've got CG, we've got audio processing, we've got automation, and VRI are a Korean CG company. So why do you want to speak to us? If you're wanting to go to maybe a more scalable and future-proof environment, you don't want to reinvest in your complete machine room, come and have a talk to us. We have something that may be very interesting to you. If you've already strategically decided you would like to go to a cloud-based processing environment, again, come speak to us. We have a really compelling solution there. For system integrators, we offer the opportunity to offer very highly customizable and scalable systems. That's the same for broadcasters, of course, but for SIs who want to have a lot of flexibility in what they're doing, they can use Origin to great effect. And to technology providers, like we did with the plumbing at the beginning with SDI and ST2110, this allows OEMs, people who make CG, video servers, etc. It allows them to focus on what they know best, which is the application, and they don't have to work in the plumbing. Thank you. That's all I have to say on it. If you want to come speak to us, you know where we are. Please do come and do it. Our objective here, again, I remind you, is we want to do this with no compromise. We want to make your workflows better than they are today, easier to manage, and actually the performance we get out of these on standard platforms, and we use AWS for development because AWS are very interested in this and they give us credits. We run in any cloud. We don't care. We just develop in AWS because they give us free credits for it, so that's the easiest way to do that. So we can do it without compromise. We want to at least improve, at least give you the same workflows you have today, but ideally improve them. In general, we improve the latency substantially. There's opportunities for everybody in software transformation. There really are. Thank you very much. This is me.
Thank you. Grazie.
Was that too long?
Thank you.
I apologize if it was too long.
That's okay, don't worry. Ok, grazie. Adesso, diciamo, se c'è qualche domanda, qualcosa, sapete che insomma potete scriverci o ci vediamo. Se volete, c'è qualcosa da mangiare, siamo qua. Grazie mille. Grazie mille. Grazie a tutti, anche alle persone su YouTube.
Solo una parentesi, chiunque volesse testare, provare i prodotti che io vi ho descritto precedentemente sono disponibili attraverso la CVE. Tutti questi boxettini che avete visto qua sul tavolo, basta richiedere o a Alessandro o a Mauro, nel giro di breve tempo possiamo fare una demo, un test sulla vostra facility.
Esatto, sì, su Monarch Edge già sono disponibili, il resto in qualche giorno li abbiamo qua, quindi quando volete. Grazie.